62%.
Yeah, that's a rough number.
It is. According to the 2025 Forrester research data we're looking at today, 62% of enterprises completely failed to achieve their projected AI return on investment last year.
Completely failed.
Right. So, I mean, if you are a European business leader, a CTO, or, a systems architect listening to this right now, I really have to pose a serious question. Are we experiencing a deflating AI bubble?
Oh.
Or are companies just throwing incredibly powerful technology at the wall without a real plan to measure if it actually sticks?
Right.
So our mission for today's deep dive is to analyze this really fascinating document from AetherLink. It's called Agentic AI and Multi-Agent Orchestration, Den Haag's Enterprise Guide 2026.
And that 62% failure rate, I mean, it illustrates exactly why this precise moment matters so much for businesses right now.
Definitely.
Particularly here in Europe and specifically in tech hubs like Den Haag, because we're sitting right in the middle of a fundamental architectural shift in 2026.
A shift that a lot of people are missing.
Exactly. Organizations are realizing they're trapped. On one side of this chasm, they have these basic, isolated genie-eye chatbots that every department experimented with.
The ones that just summarize emails or whatever.
Right, exactly. And then on the other side, they have absolutely undefined ROI and, frankly, really nervous boards of directors.
Yeah, asking where the money went.
Exactly. So the imperative right now is transitioning out of that trap and into what the industry calls agentic AI.
Right.
And these aren't systems that just, wait around for a prompt to answer a question. They actively pursue goals.
Which is a huge difference.
It's massive.
Yeah.
70% of enterprise tech leaders see this transition as critical for maintaining any kind of competitive edge over the next 3 years.
But the deployment gap is huge, right?
It's huge. That's the real opportunity for you listening to this. Only 23% have actually built operational multi-agent systems.
Which means if you can figure out how to be in that 23%, you have a distinct operational moat. So let's start with the fundamental nature of this shift, because looking at the AetherLink guide, the root cause of that massive deployment gap is really a misunderstanding of the mechanics.
People just don't get what it is.
Right. People hear agentic AI and they just think, oh, it's a better chatbot.
Yeah, just a smarter version of what we had last year.
Exactly. But standalone chatbots, the ones we've all been testing for the last few years, they're purely transactional.
Yes.
You ask a question, you get an answer, and the process basically dies right there until you initiate it again.
Right. It's totally passive.
But agentic AI is an entirely different architecture. I mean, it actively coordinates across different enterprise departments.
Yeah, and it manages exceptions, too.
Right, like when an API fails or a data point is missing. And crucially, it actually learns from the outcomes to optimize the next run.
I really think the hype cycle did enterprise architecture a massive disservice by, conflating everything under the umbrella of AI.
Oh, for sure. Everything is just AI now.
Right. But the Aetherbot platform that's mentioned in the source material is a prime example of this evolution in mechanics.
How so?
Well, it doesn't just execute natural language understanding to generate a summary. It integrates that cognitive layer with actual workflow orchestration protocols.
Okay.
And EU AI Act governance parameters. It's actively executing multi-step business logic.
The best way to visualize the mechanism here, I think, is to move away from that assistant model entirely and think about a commercial restaurant kitchen.
Okay, I like that.
So a traditional chatbot is basically like a microwave.
Right.
You put a prompt in, you press a button, you get a meal out. It's one-to-one.
Very linear.
Exactly. But agentic AI, specifically multi-agent orchestration, that is the entire kitchen staff. You hand the system a high-level goal, like prepare a 5-course meal, and the system breaks that down itself.
So you're not micromanaging?
Not at all. You have an expediter routing the tickets. You have a data query agent acting as the line cook, pulling raw ingredients from your SQL databases.
That's a great way to put it.
And you have a compliance agent acting as the sous chef, right? Making sure nothing violates dietary restrictions.
Right. Checking for peanut allergies, essentially.
Exactly. And they're all working asynchronously, passing tasks back and forth without you having to, prompt every single slice of the knife.
That kitchen analogy, it perfectly captures the division of labor.
Yeah.
And it also really highlights why that 78% of leaders know they need to make the jump. I mean, if your competitor is operating a fully orchestrated kitchen...
And you've just got a bunch of microwaves.
Right. If you're still trying to run an enterprise by microwaving one task at a time, you simply cannot compete on throughput. or cost for that matter.
No way.
However, operating a commercial kitchen with autonomous agents making split-second decisions, that introduces a pretty severe architectural challenge. Exactly. How do you prevent systemic collisions?
Because if two autonomous agents start, like, fighting over the same database resource,
Or one gets caught in a logic loop.
right, they could theoretically take down your entire enterprise resource planning system in a fraction of a second.
Which is terrifying for an IT director.
So you need a centralized expediter. You need orchestration.
And the architecture calls this the control plane.
The control plane.
Yeah.
Yeah.
It's this intelligent middleware that sits above the individual agents. So it isn't doing the specific tasks itself.
It's just bossing them around.
Pretty much. It's managing agent routing, handling dynamic resource allocation, and providing real-time governance checks.
Okay, but does it actually speed things up?
The performance metrics of implementing this architectural layer are staggering, actually.
Really?
Yeah. McKinsey's 2026 study found that organizations deploying these orchestrated control planes saw 34% faster end-to-end process execution
Wow.
and a 41% reduction in manual human touchpoints.
Okay. A 41% reduction in humans having to step in to fix broken processes. I mean, that's a massive operational win.
It's huge.
But, okay, if you are a systems architect listening right now, the phrase centralized control plane running real-time governance on every micro decision, I mean, that is setting off alarm bells.
Oh, absolutely. Bottleneck fears.
Right. Putting a central bottleneck in charge of thousands of autonomous agent interactions, that sounds like a recipe for terrible computational latency.
Doesn't sound like that.
And I understand the guide points to using localized Dutch data centers to gain, regional latency advantages for enterprises in Den Haag.
Yes.
But putting a server down the street only solves network ping time.
Right, the physics of the wire.
Exactly. If the AI boss has to run a complex risk model on every single data handoff between agents, the software itself becomes the bottleneck.
Yeah.
So how do they actually code around that computational overhead?
Well, the software engineering behind this has evolved rapidly to solve that exact bottleneck. You don't run heavy governance models synchronously on every minor action.
Oh, I see.
Right. So the control plane utilizes dynamic API gateways and what they call token bucketing algorithms.
Token bucketing?
Yeah. Essentially, agents are granted a specific budget of operational tokens for low-risk routine tasks, like pulling standard data from a CRM.
So they don't have to ask permission for the boring stuff.
Exactly. They can execute those rapidly without checking in. The heavy governance checks are parallelized.
Ah, okay.
They run alongside the workflow for high-risk actions. And for ultimate system stability, the text actually outlines the mandatory inclusion of software circuit breaking mechanisms.
Okay, so you're implementing software circuit breakers to just like sever API connections the millisecond an agent starts hallucinating.
Yes. Containing the blast radius before it cascades.
Wow.
Yeah, failure isolation is really the non-negotiable foundation of multi-agent systems.
That makes total sense.
Because if you have an ecosystem of agents passing sensitive data back and forth, and, one agent goes rogue or starts generating infinite API calls.
The whole system could crash.
Right. So the control plane acts as that circuit breaker. It instantly isolates the problematic agent, revokes its operational tokens, and routes the workflow to a fallback protocol. Or it just triggers a human escalation.
So the system scales securely specifically because the failures are compartmentalized at the software level.
Exactly.
Okay, so we have a scalable lightning-fast architecture. The agents are executing. The control plane is dynamically allocating resources. The software circuit breakers are primed.
Everything's humming.
Everything is humming. But a CTO cannot take a technical win to the board if it violates regional law.
No, they cannot. And we are talking about Den Haag here.
Right, practically the epicenter of EU governance. So we really have to look at how this autonomous machine remains legal, which brings us to the EU AI Act.
And the mindset shift required here is profound.
How so?
Well, the AetherLink guide argues that enterprises have to stop viewing EU AI Act compliance as a bureaucratic tax,
Right.
and start engineering it as a competitive moat.
Interesting.
The source outlines a 5-stage AI maturity journey, and the vast majority of organizations are currently stuck in stage 1.
Which is what? Just playing around with it?
Pretty much. It's
Yeah.
siloed experimentation. But moving to stage 3, which is orchestration, means building comprehensive compliance frameworks directly into your centralized control planes from the very first line of code.
Okay, so you are basically baking the regulatory parameters into the API gateways themselves.
Exactly. And incorporating those parameters early makes early adopters incredibly attractive to massive enterprise clients.
And government procurement divisions, I'd imagine.
Oh, absolutely. Because they are verifiable, the risk is mathematically mitigated.
Right.
The guide actually highlights EtherMind, which is AetherLink's AI strategy division. They focus specifically on embedding these frameworks like dynamic risk assessment, mandatory human-in-the-loop escalation trigger, and real-time bias monitoring directly into the middleware.
I mean, verification of an autonomous system still sounds like a regulatory nightmare, though.
It can be.
Because in traditional deterministic software, if an auditor knocks on your door, you can just pull the code repository and show them the exact decision tree.
Right. A leads to B.
Exactly. But with agentic AI, these models are probabilistic. They're constantly adapting.
Yeah.
So if an enterprise denies a citizen a municipal service, let's say, and the regulator demands to know why, how do you achieve explainability when 5 different AI bots dynamically collaborated to make that decision in what is essentially a black box?
Well, the control plane eliminates the black box entirely, and this is really where the architecture proves its worth.
Okay.
Because every single interaction, every API call, and every data handoff between those 5 different bots has to route through the control plane, right?
Right.
So the system generates an immutable audit trail. It captures state snapshots and telemetry data at every single step. Yeah, you aren't trying to reverse engineer a neural network's thought process. You are providing the regulator with a documented, cryptographically hashed workflow tree.
So you can literally just point to the log.
Exactly. And point to the log and say, Agent A queried the citizen database at this timestamp. Agent B applied the eligibility model. Agent C flagged a missed document. And then the control plane authorized the denial based on Rule 41.
That level of traceability is incredible.
It's mandatory now.
Right. But let's connect this back to the CFO's desk and that terrifying 62% failure rate we opened with.
Let's do it.
Because you can build the most beautifully governed, fully auditable multi-agent system in Europe. But if it doesn't actually generate revenue or drastically cut operational costs, it's just a very expensive, compliant toy.
Giant paperweight.
Exactly.
Yeah.
So how is this architecture actually proving its return on investment in 2026?
Well, organizations are failing because they're still relying on vanity metrics.
Like what?
Like number of prompts generated.
Yeah.
Or hours of meetings summarized.
Stuff that doesn't actually hit the bottom line.
Exactly. Or worse, they deploy the technology and then retroactively try to find a metric that justifies the spend.
Oh, yeah, we've all seen that.
Right. But the guide insists on measuring across 3 rigorous dimensions. First, operational metrics. So end-to-end process execution time and specific error rates.
Okay.
Second, financial metrics. Direct hard dollar cost savings and full-time equivalent resource reallocation.
Basically, are we saving money or moving people to better tasks?
Exactly. And third, strategic metrics.
Yeah.
Speed to market and competitive positioning.
Makes sense.
But achieving these metrics at scale, it really requires shifting from piecemeal software deployment to building what they call an AI factory infrastructure.
The AI factory concept. I mean,
Yeah.
if I'm an IT leader looking at my budget, that sounds like a massive capital expenditure. What exactly is the infrastructure of an AI factory?
Well, it is a continuous integrated ecosystem rather than just a collection of separate tools.
Okay.
So your data ingestion pipelines automatically feed vector databases.
Right.
Those vector databases ground the AI agents in real-time enterprise knowledge. Then the agents execute workflows via the control plane.
And it all loops back around.
Exactly. The telemetry data from those workflows automatically loops back to refine the data pipelines.
Wow, okay.
And according to Accenture's 2026 Technology Vision Report, companies that invest the capital to build this integrated AI factory infrastructure, they report 3.2 times higher ROI than companies that just buy isolated point solution tools.
3.2 times. That's massive. But deciding to implement an AI factory immediately triggers the classic enterprise dilemma, right? Build versus buy.
Oh, always.
Do you hire an army of machine learning engineers to build this entire continuous loop from scratch? Or do you just buy an off-the-shelf platform that might not fit your exact workflows perfectly?
It's a tough call.
The AetherLink guide actually introduces AI lead architecture, specifically citing the development services of AetherDV to help organizations systematically navigate this. They advocate for buying commodity functions like, standard optical character recognition for document processing.
Because why build that yourself?
Exactly. And reserving your internal engineering resources to build custom components for actual strategic differentiation, like a proprietary pricing model agent.
That allocation of engineering resources is absolutely critical. You don't burn your IT budget reinventing the wheel for basic customer service routing.
Right.
You buy that. But you build the highly customized multi-agent model that optimizes your unique supply chain logistics.
So let's ground all this abstract architecture in a concrete, practical reality,
Good idea.
because the guide includes this phenomenal case study about the Den Haag municipality.
Oh, that's a great one.
Yeah, they wanted to overhaul their permit processing system, so they set up a digital processing center using Agentic AI.
And they didn't just deploy a chatbot to answer citizen questions.
No, they built the full kitchen, like we were saying earlier.
Right.
They deployed agents for document intake, eligibility verification, cross-referencing compliance databases, and managing applicant communication.
All working together.
All working together. And before this system went live, the average permit processing time was over 25 business days.
Which is wild.
And 40% of those applications required a human to manually intervene, track down a missing document or fix an error.
It's just a massively inefficient drain on public resources.
Exactly. But post-implementation, that 25-day processing time plummeted to 4.2 days.
Wow.
That is an 83% improvement in speed. The manual human intervention rate dropped from 40% to 8%.
That is incredible.
And the financial metric, which is the big one, it generated 2.3 million euros in annual cost savings strictly through resource reallocation.
That's the real ROI.
Right. The municipality could move human workers off of tedious data entry and onto actual complex urban planning initiatives.
The numbers are spectacular.
Yeah.
But, as analysts, we have to look at the shadows those numbers cast.
Uh-oh. What's the catch?
Well, the sheer scale of that success obscures the brutal reality of the implementation.
Okay.
If you read the fine print of that case study, achieving an 83% improvement required 6 months of grueling, unglamorous data infrastructure work before a single agent was ever deployed.
Wow. 6 months before they even turned the AI on.
Before they even began testing the models.
That's a long time to wait for a win.
It is. The municipality had to map out decades of undocumented human workflows. They had to standardize legacy APIs that hadn't been updated in years.
Oh, wow.
They had to normalize fragmented databases so the AI agents could actually read the data in the first place.
Right.
And most importantly, they had to establish comprehensive baselines.
The baseline metrics.
Yes. The core lesson from that 62% failure rate we talked about is that if you do not establish rigorous baseline metrics before implementation, your ROI means absolutely nothing.
It's like embarking on a strict fitness regimen without stepping on the scale first. And then 6 months later, guessing you lost weight because your clothes fit differently.
Yeah, you cannot put that in a board report.
Definitely not. If you don't meticulously document exactly how much time and money a broken process costs you on day one, you really can't claim a 2.3 million euro victory on day two.
No, you can't. Organizations that attempt to add metrics retroactively will never achieve credible board-level ROI documentation.
It just looks suspicious.
It does. The foundation of data cleanliness and workflow mapping is entirely non-negotiable.
Okay, so if that rigorous, governed, data-clean AI factory is where the absolute best enterprises are operating in 2026, we have to look at where the frontier is moving next.
Oh, things are moving fast.
Really fast. We've spent this deep dive talking primarily about text-based agents, right?
Yeah.
AI that processes PDF documents, reads emails, queries SQL databases, and outputs text. But the guide indicates the puck is moving rapidly toward multimodal AI.
Yes, the multimodal shift.
We are talking about expanding an agent's perception beyond text to interpret visual data, audio signals, sensor inputs, and unstructured data all simultaneously.
And this shift from unimodal to multimodal architecture completely redefines what an enterprise can automate.
How does it even work, technically?
Technically speaking, these new models use shared vector spaces, so they map different sensory inputs into the same conceptual understanding.
Okay, lost me a little bit there.
So, for example, the AI doesn't just read the word overheating.
Right.
It processes the acoustic vibration data from a physical turbine and maps it to the same vector as the text in the maintenance manual.
Oh, wow. Okay, that's wild.
Yeah. Think about the implications for industrial sectors. You could have manufacturing agents continuously interpreting live multi-sensor streams from a factory floor.
And taking action.
Autonomously adjusting machine calibrations in real time without human input.
Unbelievable.
Or medical AI agents that don't just summarize clinical text, but autonomously cross-reference that text while analyzing a live ultrasound feed.
I mean, The capability there is astounding. But honestly, looking at it through the lens of a CTO, it drastically elevates the risk profile.
Oh, exponentially.
Because if a text-based agent hallucinates, maybe it drafts a bizarre internal email, right?
Yeah.
Or improperly denies a permit that a human citizen can then appeal.
Right. It's a bureaucratic inefficiency.
Exactly. But if an agent is interpreting visual and physical cues, misinterpreting a visual signal on a manufacturing floor, or misreading an audio cue in a physical security setting,
The stakes are way higher.
the AI is moving from a read-only state in the digital world to a read-write state in the physical world.
Yes.
The governance implications of an autonomous agent making physical adjustments based on sensor data, that is terrifying if the system isn't locked down.
The risk profile shifts completely from data corruption to physical liability.
Exactly.
A bad text prompt is an annoyance, but a bad visual interpretation by an autonomous agent could trigger unauthorized, irreversible physical actions.
Which is a nightmare.
That is precisely why the convergence of advanced reasoning models with multimodal sensory interpretation requires a control plane that is practically bulletproof.
It all comes back to the control plane.
It does. If your middleware cannot handle the token bucketing and circuit breaking of text data, it will absolutely collapse under the compute weight of real-time video and audio stream governance.
Which brings us right back to the foundational architecture. You cannot leap to multimodal sensor agents if you haven't mastered the basic text-based control plane.
Yeah, you can't skip steps.
Well, we are coming to the end of our deep dive, so let's distill all of this complexity down.
Okay.
If you are listening to this and mapping out your IT strategy for the next 3 years, what is the absolute most important takeaway?
Good question.
For me, it all comes back to the fact that you simply cannot fake the foundation.
No.
That Den Haag municipality case study is the ultimate proof. Every CTO wants the vanity metric, the 83% faster processing, the 2.3 million euros saved, the headline in a trade magazine.
Everyone wants the headline.
But you only earn those metrics if you have the discipline to spend the grueling 6 months doing the data cleaning.
The hard work.
Exactly. Normalizing the legacy systems, mapping the human workflows, and establishing strict baseline metrics before you ever deploy an agent.
I completely agree. And building directly on that requirement for discipline, my primary takeaway is that governance is no longer an afterthought.
Right.
It is pure system architecture. The multi-agent control plane is the central nervous system of the modern enterprise.
Oh.
Without it, you do not have an AI strategy. You just have a chaotic liability waiting to trigger a cascading failure.
That's a stark way to put it.
It's true. Embracing regulations like the EU AI Act from day one and baking those rules into your API gateways doesn't slow down your innovation.
It actually speeds it up in the long run.
Exactly. It makes you the most attractive, trustworthy, and verifiable partner in the market. It is the ultimate competitive moat.
It transitions compliance from a tax into an asset.
Exactly. And I actually want to leave the listener with a final, broader thought to mull over as you look at your own organization's long-term roadmap.
Okay, let's hear it.
We are rapidly moving into a world where multimodal reasoning AI agents handle complex, multi-step workflows autonomously. They're coordinating among themselves in real time, executing tasks from document processing to physical supply chain adjustments.
Right.
If the AI is doing the executing, what is the primary role of your human workforce in 2030?
Ooh, that's a big question.
Are they still operators grinding through tasks, or are they transitioning purely into governors of AI, managing the exceptions and setting the high-level goals for the machines to pursue?
A profound architectural and cultural question to end on. For more AI insights, visit AetherLink.ai.